So in your convergence proof, in problem number 3, you're asked to justify why this sequence converges to the number 2, and you got 2 by using your calculus intuition, right? A technique from Calc 2. And then the burden of proof, as it is with every convergence proof, is for any arbitrary epsilon that the universe selects for you, you need to choose a natural number, capital N, such that we're going to be able to draw this conclusion. For all little n's greater than or equal to that capital N, all the terms of the sequence will be within epsilon of the limit. So the limit is 2, the sequence is 2n over n plus 1. And so in this middle column, you did your scratch work, you did your algebra, to figure out that this inequality will be satisfied as long as little n is greater than 2 over epsilon minus 1. Right? So you did some algebra, figured out that 2 over epsilon minus 1 is a good threshold to use. And so we use Archimedes to choose for us a natural number, capital N, such that n is greater than 2 over epsilon minus 1. Right? And now we have to make the argument for why we know that Sn minus L absolute value is going to be less than epsilon. And so here's how you do it. We're trying to prove that this inequality holds. And anytime you're trying to prove an inequality, don't begin by writing both sides of it. Begin by writing one side of it. I'm going to write the left-hand side, absolute value of Sn minus L, and take successive steps that either are going to make my quantity equal to the next step or are going to make it less than the next step. Right? So all the steps that I take are either going to keep me in the same place on the number line, or I'm going to take a step up to the right on the number line. So what this ends up looking like in practice is it ends up looking exactly like the algebra that you did to discover your capital N in the first place. It's just when you were doing it over here, you were working on both sides of the inequality. Here, we're going to work on just the left-hand side. So we know that the absolute value of 2n over n plus 1 minus 2 is equal to the absolute value of, actually I think there was probably a negative sign in here when you did this algebra the first time. And so because that's actually equal, you'll write that into your proof. So we're going to say that this absolute value is equal to the absolute value of negative 2 over n plus 1. Right? And then in the process, you had to reason for why the absolute values can go away here. Absolute values can go away if we turn the negative 2 into a positive 2. And since n plus 1 is already positive, we'll just keep that as it is. So far, I haven't moved either up or down the number line. This quantity is exactly the same as this quantity for all natural numbers n. And so now is when the magic happens. Now is when we remember that we know something about little n. We know in particular that it's greater than or equal to capital N, and that capital N is a natural number that's greater than 2 over epsilon minus 1. And so here is where we have the opportunity to now say, because n is, I'm going to kind of write it this way, because n is greater than 2 over epsilon minus 1, if I kind of replace my n with 2 over epsilon minus 1, I'm going to get a denominator for my fraction, where the denominator of my fraction here is now smaller than the denominator of my original. And if the denominator has been made smaller, then what has happened to the whole fraction? It's been made bigger. Right? So I have replaced n with 2 over epsilon minus 1, and in the process I've gotten a quantity which is larger than 2 over n plus 1 was. But now take a look at what happens in the arithmetic, the algebra, in the denominator. 2 over epsilon minus 1 plus 1 is just 2 over epsilon. And so this is just 2 over epsilon. In other words, it's epsilon. Right? And so if we read this whole thing from left to right, we have found that the absolute value of Sn minus L is in fact less than epsilon. And all we had to do to get there was to guarantee that our little n was greater than 2 over epsilon minus 1. So when you've chosen the right capital N, the reader of your proof should be left in amazement at just how clever that you were when you chose that n, because it happened to be just the thing that made the arithmetic work out so that you've shown exactly that this quantity is less than epsilon just by itself. That's why reading a proof like this in a textbook is often really challenging, because it doesn't give you the intuition that you had to build here in the middle. Right? You don't always see this scratch work as part of another author's proof, but you have to do it in order to discover what the capital N is that makes it work out just right.